So this is the second session of this blockchain concepts. So last time we spoke about what is a blockchain network. We also discussed about a logistics use case, and then how using blockchain in logistics can benefit the people who are all interacting in that particular network, and a few of the features of the blockchain like immutability, decentralized, etc., permission and permissionless blockchains. And we also saw that blockchain is essentially chain of blocks, and each block will have certain set of transactions and the blocks information, previous blocks information, and the block number, when the block was created, etc., etc., etc. So many information about a particular block and also its transaction. And each transaction can be a money transaction, it can be a data update, it can be a file upload, or anything. A transaction can be anything which can be stored on a blockchain ledger. Okay, and these transactions will be stored inside a block, and then those blocks will form the blockchain ledger. Okay, and we also saw how a blockchain ledger can be compared with a book, where each book has multiple pages. Multiple pages has numbers. Each page will have certain page numbers, and the page will have entries. A ledger book will have certain records of financial transactions happening in a bank. Okay, or any in a shop, where what happened, how much was purchased, how much goods was, his inventory of a particular shop or a medical shop, anything. So everybody would maintain a book and paper, right? Book and update their entries. So similarly, blockchain can be considered as a book, wherein each book has a page, and pages will have their own transactions, and each page will have a page number and all the transactions written over it. Okay, and also we saw something about hash. Hash is I'll talk about hash today also. What is its significance of hash and hashing? Okay, hope we are there. Everybody's with me. Do you have any queries with respect to our previous session? I can.
You can proceed, I think.
All right. Okay, fine. So today we'll see what I had told about a block and block structure, right? Block of data, right? Structure stored in the memory. How it will be stored? It could be in a file, right? Stored in the computer. Okay. So this is how a blockchain's Bitcoin blockchain's data structure will look like. It will have a I've got this data by issuing a command called get block 71. It says that I'm showing you the details of a block number 71 of a private blockchain network which I've maintained in my system. Okay. This is not from public blockchain network. This is my private blockchain setup. Okay, so it will have, each block will have a hash. Okay, this is a hash. Take the first yellow mark, that is a block's hash. Okay, and there will be something called as a miner. We'll talk about mining and a miner in probably this session or next session. So each that is stored as a. If you notice, all this data being written is all jumbled strings, or these are letters and numbers combination. Okay, these usually. The miner, what you see in the right hand side of a miner is the address of miner. In a blockchain network, any transaction will happen through a blockchain address, be it Bitcoin blockchain or Ethereum blockchain or any other blockchain. All the transactions happen through a blockchain address. I will show how an address looks like, and what are all and each address will have a public key and a private key as well. Okay, to initiate and to do some transactions. Everybody that also we'll talk about it. Okay, so if you see the miner, there is an address of a miner, and confirmation, size of the block, height, that is block number 71 is the height of the block, and then version, and then Merkle root. This is the block's root which I talked about earlier. So we saw that a block will contain several transactions, and those transactions can be combined together, concatenate. Two transactions will be concatenated together to form a tree, a branch of a tree. That those two branches can be combined again, concatenated and hashed, and created a root of that particular tree structure. Okay, so that is a Merkle root. So this 7635AA7A, that long string, right? That is a Merkle root. Okay, and that is found by hashing the whole data present in that tree. Okay, if any data in the tree changes, the Merkle root also will change. So that is why we say that a blockchain is immutable. If at all you change the data, the whole block structure and the blocks hash, everything will change. So you cannot proceed because this data will be replicated in multiple systems. So if you are changing in your system, you that data will remain only in your system. You won't be able to connect to other systems because they all have a previous data which is accepted and agreed upon by all the computers. So if you change the data in your system, you will no longer be able to communicate or connect to that network. That is why we say the blockchain is immutable. The data is secured through these mechanisms. So every transaction will be hashed and stored inside. The hash value also will be stored inside the blockchain. This block data will be replicated on all the computers. Okay, and it also shows the time. Okay, this is 1605369. That is this many number of seconds after 19 over. Okay, that is the epoch time. If you in computers we say we start everything with a particular timestamp after this many seconds after 1900. And nonce is another number which is used to compute the calculations. Okay, these two to reach this block structure. And then it also contains what is called as a previous block hash. The last entry here is called as a previous block hash. It's a that is also containing the hash of the previous block. That is block number 70's block hash will be 02, starting with 002. Okay, so this is essentially a block structure. I can show you another blocks data. Okay, I have another this is my Ethereum network. Okay, I can show you that the currently it has a 12 blocks created, and then you can see my terminal, right?
Yes, sir.
So what I'm doing is I'm showing eth.get block. That is a command to show the blocks structure. Okay, this is a different block structure. Okay, this is of Ethereum blockchain network. Okay, it also contains the data. What is the gas limit? What is the hash of the block? This is extra data which is logs usually stored. This is a miner. Here, this is my private blockchain network. So miner is always 0, and nonce is something. What is a block number? What is the parent block's hash? A recipient root. All these things are similar to what I saw. It's a block, a Merkle root, and etc. Right? State root, and the number of transactions. What is the transaction? So all this information will be unique to this particular block. And if I see block number 11, right? So that will be having a different block, a different data altogether. Okay. Essentially this 8B88. Yeah. So if you see parent hash of block number 12, this is block number 12, and its parent hash is 0x8B88. Okay. If I look at that, is the block number of block hash of 11. Block number 11. So if I look at block number 11, its block hash is 8B88. Okay. And block number 11's parent hash is 73EE92. So if I go and look at block number 10, it will be 73. So that is why this blocks is linked together. Okay, and it will have parent hashes 2347. So 2347 will be block number 9's hash 21347. So you got the link like that, right? So block number 10 is connected to block number 9. It has a link to block number 9. Block number 11 will have a link to block number 10. Block number 12 will have a link to block number 11, like that. So that like that, the chain is formed, and each block will have a certain number of transactions. Here, each block has one particular transaction. Okay, I will demonstrate how a transaction is created in Ethereum. Okay, I will show you how it is created, how a transaction is created, and how it is getting added onto the blockchain network. I'll show that. Okay, so this is the block structure of Bitcoin blockchain network. Okay, and this is what I said about hashing. So I think we told about hashing in the last session. So that is SHA is a secure hash algorithm which is used to calculate a single digit. Okay, that's a mathematical algorithm which is used to map any long data. The data could be very small or a big string or even a longer multiple lines or even a book. Everything can be converted onto a single long string. That will be a size. The size of the string will be fixed for any data. Okay, if you create a hash of a book and hash of a letter A or hash of letter B or hash of a word hello world, all the hashes will be of same length and it will be unique. So you cannot find a duplicate hash of different data, and the hashing algorithm is in such a way that if you execute that hashing algorithm multiple times on same data, you will get the same value. It will always return the same value. So that is the typical hashing algorithm. So I have written here is the quick brown fox jumps over the lazy dog. That is a long string which I have written. When I do a hash, this is a small utility which helps me to create a hash. It says that C090 C03905FC. That is a long string. That is a hash of the long this particular sentence. Okay. Now, if I add a single dot, okay, a full stop after the dog, and then compute the hash again, it will be an entirely different hash. Hash will be different. And if you see, I have put a comma at the end. Okay, the result of that is entirely different string. And then if I execute the same command again, C0C90, right? It will return the same hash. Okay, I can show you that also now. So if I echo hello world, and then so this is the command to generate a hash. So you can see that it is C023D0. Okay, if I change the H to capital, it will be entirely different. If I execute again, it will return the same value. Okay, and if I put a space, it is entirely different. So the computation is entirely different for computation is same, but the data resulting data for different kinds of strings will be different and it will be unique. Okay, so that is the mechanism of hashing. So do you have you ever realized or do you know where this can be used in by any chance, this kind of why do we use this hashing? Can anybody think of some use? It's okay. It's an entirely new thing to you. That's fine. So I can tell probably you will be able to relate how its use of hashing. Okay. So if you would have sent emails to people, right? You would have attached the documents or images and then sent. Okay, and maybe many of us would have used WhatsApp, and then the data you type in certain data and then send it to people. Okay, and you have sent a file over the internet. Okay? If you are attaching a file and then sending the data to somebody else across the world, how the other person is sure can make sure that that is the file which you had sent, that nobody has modified that file in the middle. It is going from your computer in India over the internet, and then it is reaching at a computer in a person who is sitting in Australia. Okay, let's say you are sending data over the internet, and then you have attached a file and then sent. How can you make sure, how can the other person make sure that the file which you entered is actually sent by you, and also the content has not been changed by somebody else? So there is no way he can measure that. But modern systems automatically what they do is, uh, suppose if I uh, create a hash of that particular file, okay, and then I note that down in my paper, okay, and then after sending that file, I'll call him up and then ask to compute the hash of that particular file he has reached. Okay, and then I will ask him to compute that hash and then ask him to read out whatever the long string he has computed using that over that file. If the long string what he got, if the hash is different when he executed, if the hash is same, you can be 100% sure that nobody has modified your file over the while during the transmission. If the hash is different, you can be 100% sure that somebody has modified the data in the middle. There is something has happened. The file got corrupted, or somebody changed some data in the middle and then modified the file. So essentially, the hashing comes in use to check the data integrity, whether the data is lying, has been altered or not. You can store the data in a file and then in a database, and also store the hash in a database. Okay, and after 20 years you come and check, and then you calculate the hash of that file, and then if it is different from the hash, you can be sure that somebody has modified the data in the file. So hashing is essentially to check whether the data is the same as before, okay, or during the transmission data has been modified or not. Make sense?
Yeah, got it.
Okay. So you have heard of encryption and decryption also, right? Cryptography is a technique by which you can encrypt data during transmission. Okay. There are various mechanisms of encrypting a data. Encrypting means to convert a readable data to some other format, so that any person who is able to read that string in the middle is not able to understand what the actual data is. Okay, maybe you create a jumble out of you basically jumble the strings in the data which you want to send, in the message you want to send to somebody. You basically jumble the letters, so that is also a kind of encryption. Let's say you are increasing 5 alphabets in a name. Okay, that is also an encryption. So the other person who is reading this message, if he knows that he has to decrease 5 alphabets from each character in that string, he'll be able to figure out what is the original data. So that is a kind of encryption. And the decryption means to convert the jumbled string back to the original data. So let's say this is a string. Okay. When you look at it, it doesn't make any sense, right? It says AK, NBJ, BG, HM, right? It doesn't make sense what it actually means. So, but what I have done is I have basically, if you know, if a person who is reading this, if we know that this to increase one alphabet from on each alphabet in this particular word. So it essentially means blockchain. So basically, A is incremented to one, incremented by one, and then I get B. K is incremented by one, I get L, like that. So that is a kind of encryption. So idea is you convert a message into some gibberish data or an encrypted data, so that the person, middleman, whoever gets access to the data, is not able to read the data. If you probably you would have seen that when you if you are using WhatsApp now, they say that WhatsApp is end-to-end encryption. Nobody will be able to decrypt the data which is transmitted across the internet. Only your machine and then your device and the sender's device will be able to decrypt the original message which was sent. Okay. And there are types of cryptography which helps you to encrypt: symmetric cryptography and asymmetric cryptography. That is a detailed mathematical study or cryptographical study, which when people are going to learn computer science, they'll be able to learn symmetric cryptography in detail. But in to tell in as simple what it means is, cryptography means encryption and decryption of a message using the same key. Okay. Here in this case, the key is that increase the letters by one. That is the key. I say that I am sending you a string, you increase one by increase alphabets by one. That is a key. So the other person knows that he has to decrease by one. That is a symmetric cryptography. There is that is kind of symmetric cryptography. You use one particular key, okay? And there are tools and algorithms which help you to generate cryptographic strings by using a key. Okay? And there are the same algorithm will be used to decrypt the data using the same key. So the key could be that is called ciphering data, cipher text, and the original data. If you are you encrypt the data using a cipher text, you also decipher the data using that particular cipher text, or what we call as a key to decrypt the data. Okay. And there is something else which is called an asymmetric cryptography, which uses something called as private public key encryption and private key for decryption. This asymmetric cryptography is what is being used in blockchain and various other technologies where secure data transmission is used. When somebody is sending a message is being sent from one person to another over the internet, he uses his private key to encrypt, and he uses whenever he is sending a data to other person, right? Alice is sending a data to Bob, so Bob's public key will be known to Alice, and then Alice encrypts the data using Bob's public key, okay? And Bob is having access to Bob's private key. So only Bob will have his private key. So Bob will be able to unlock the data original message using his private key. Nobody else has access or information about Bob's private key. Only Bob has private key, but Bob has exposed his public key to everybody. Everybody knows Bob's public key. They will encrypt the data using Bob's public key. Bob will be able to decrypt the data using his private key. So that is a technology which is being used in widely used in blockchain and also various other technologies. It uses private key, public key encryption. It is called as key pair. Okay, private and public key pair.
Just, I would like to
Yeah.
interrupt here once. Now, as you said, this Bob's public key and private key. Private key, as a matter of policy, they have decided that they will not access it. But if they want, let's say we talk about WhatsApp. If they want, can they access the private key of Bob?
No.
No.
Bob, no. If Bob uses his private key, if he has shared his private key to somebody else, they will be able to use it. By default, only Bob has his private key, access to his private key.
So WhatsApp, if they want, also they cannot access the private key. But they
It
have
is
the
with
technology.
respect to you. I'm not telling that WhatsApp uses the same technology.
Okay.
I know that when if I compare WhatsApp with WhatsApp, this question would arise. But
Okay.
WhatsApp might be using a different mechanism. That may not be public key, private key encryption, but it uses an end-to-end encryption.
Yes, end-to-end encryption is there. Okay, no problem. You can carry on.
Yeah. Okay. So a blockchain transaction is always done using private key, public key encryption technique. Okay. And as I said earlier, distributed ledger, what a distributed ledger is, and what a blockchain is. Blockchain is decentralized, distributed, and often public or private digital ledger, and it contains records of block, and blocks contain transactions. And distributed ledger, that is also called shared ledger. Okay, that contains the blocks information. It contains the blockchain in itself. The speciality of distributed ledger is that the ledger itself is replicated, and everybody in the network will have the same data. They will have the same copy of the ledger. So that is the primary feature of blockchain, okay, and distributed ledger technology. Hope you are clear on this concept, right?
Yeah.
Okay, so there are types of blockchains. I had mentioned about different types of blockchain earlier. Main two is a public blockchain network and private blockchain network. Public blockchain network is hope many would have heard of Bitcoin public network. There is Ethereum public network. There are various other public blockchain networks which supports which is using these technologies. Some of them use Bitcoin technology, some blockchain technology. Some of them use Ethereum's blockchain technology. What they do is they take a copy of Ethereum, or they fork it and then create their own blockchain networks and then make it public. And then they can they can create their own public networks. People can join. They can do transactions. They can buy cryptocurrencies. They can do transactions. They can do trading. All those things can be possible using public blockchain networks. Okay, there is a difference between Bitcoin blockchain network and Ethereum blockchain network and various other blockchain networks. Because Bitcoin blockchain network uses only financial transaction. It uses only transactions with Bitcoin. Every transaction is involving Bitcoin. But Ethereum and other blockchain networks may not be cryptocurrency transactions. It can also have data transfer also. That is the a primary difference when Ethereum network came into existence. Bitcoin was using only cryptocurrency. Ethereum also supported transactions or transactions which involved data. If you want to store some data or broadcast some data, you can use a Ethereum blockchain network. And there are various private blockchain networks. Primarily, Corda is one private blockchain network. Hyperledger, that is by IBM. Corda is from a company called R3. And there is another network called Quorum, that is also a private. That Quorum is now public as well. So that is also part of Ethereum. And there is another type of network called multi-chain. There is another blockchain network called BigChain DB, etc. There are various private blockchain network platforms available in the market. All of them are freely available, and then there are enterprise versions which people have to buy license and then do. I basically work on these kind of blockchain networks. I primarily earlier what I said about logistics use case, right? Those use cases which involve multiple entities. It could be hospital, it could be logistics company, courier company, airports, manufacturing company, or all these people may not want to go and join on a public blockchain network. So what they do is they will create a network of their own. They form a consortium of companies. There are consortium like Beta. There is something called Beta. It's called Blockchain in Transport Alliance. There is some 750 organizations who have joined that consortium, and then they are creating a small blockchain network, private blockchain network. People have to pay and join the network and then do transactions. Okay, so that is private blockchain networks, and this is the what we hear more is public blockchain network, which involves Bitcoin and other cryptocurrency transactions. Okay, should I move ahead?
Yeah.
And earlier I told about blocks and ledger, right? Let's see how a block gets added to a ledger. Okay, so this is a blockchain network. You can see I've shown 4 computers in my blockchain network. This is a smaller network for simplicity. Each uh, each computer in the blockchain network is called as a node. Blockchain will have multiple nodes, several computers in the network. Each node will have something called as a ledger, shared ledger. Everybody will have same ledger, same copy of the ledger. That is a distributed ledger. And I have also shown these blocks, that chain, right? That is a chain of blocks. When somebody do a transaction, this image which I've picked up, right? That is from class 11 computer science textbook. They have a small section which talks about blockchain transaction. What happens when a blockchain transaction? Somebody will connect to the blockchain network. They will request a transaction. A block gets created. Okay, if you can see, a block gets created. If you can see the latest one particular block has got added. Okay, this block is requested, is broadcasted onto the network, and there are people who will look at this particular data in that particular transaction, and then there are softwares, there are computers in the network which will validate the data in the transaction, and then they verify that this is a genuine transaction, whether the transaction created contains all the information. There is a from, there is a to, there is an amount which is mentioned, there is a token, cryptocurrency information, or the data's information. Everything will be validated by the computers in the network, and then finally it will be verified by all the nodes, and then it will be accepted by all the nodes. So that the block before getting added on to the ledger, it has to be accepted by all the computers, and then once they are accepting, block gets broadcasted to all the networks, all the computers in the network. So everybody will update their own ledger. Okay. So
by consensus.
yeah. So that is I was coming to the word consensus here. Consensus means everybody is in agreement that I will also, this data is clear. You have somebody has created a block number 12. I will also agree to that particular data being added onto the ledger. I will also update my block. So my block is also updated to block number 13. Like that, it goes like that. So everybody will update and then say yes, okay, my block is in sync with the whole network.
So, I mean, everybody has to agree, or if they
They
don't
will,
disagree, or it,
there is no such thing called they will disagree. If they will shout a disagreement, the computer will send a disagreement saying if that particular data has some bad information, could be wrong information, the data not formulated properly, and then it is not signed properly. Most of the signing or signature gets added by the computer whom you are doing a transaction itself. It will be validated by the node which you are connecting, and then it will be broadcasted. And the thing is, there are certain validation saying that the same data should not exist in different different blocks. Okay, uh, there is a concept called double spending. Okay. Double spending means let's say I have 100 rupees in my hand, in my wallet, in my purse, in my account, 100 rupees, and I say that I am giving 50 rupees to Satish. I write in the ledger saying that there is a transaction which says 50 rupees to Satish. There is another transaction which says I will give 50 rupees to Ram. I'll also write 50 rupees, the same 50 rupees will be sent to let's say Rohan. So you cannot do same transaction in whenever you do using currency, right? What happens is that you give the actual currency to the other person, and whenever you do online transaction, your bank will maintain something called as a bank balance. Okay, you do a transaction saying that I am giving 50 rupees to other person using, let's say, Google Pay, Phone Pay, or any normal transactions, right? Your bank balance gets deducted by 50 rupees. It will say that you have now transferred 50 rupees to Satish, you will have only 50 rupees balance. And if you do another 50 rupees to say Ram, your balance will become zero, and the bank will not allow you to do another transaction. It will say that you don't have sufficient balance. Correct? But the blockchain is a bit complicated in a manner saying that there is no such thing called balance of Sanjeev or Satish written anywhere. The balance gets calculated from all your previous transactions. So if you have got 100, and if you do 50, okay, 50 transfer from that, 2 entries will be there. He has sent 50. He has now his balance is now 50. There is actually no. It doesn't say that he has balance. It will say there are 3 transactions. One was 100 incoming, and there is 2 transactions later. One is 50 to Satish, and then other one is 50 to myself. If I initiate a transfer saying that 50, I will send 50 to Satish, it means that I will that my transaction will have 2 outputs. It will say 50 goes to Satish, 50 remaining 50 goes to myself. So it maintains a certain set of transactions in all the blocks. Those transactions are written like that. And the computers will compute these calculations on the fly. They will go through all the transaction data from of that particular address, all the historic transactions. It will parse through all the data and then recompute the and finalize whether this particular person is eligible to do a third transaction. It gets added like that. So it also prevents something called double spending. You cannot do transfers using same currency, whatever you have. So this is how a blockchain transaction will normal blockchain transaction looks like. Somebody sends a transaction request, and then the transaction is broadcasted peer to peer. Okay, it is broadcasted all to all the network. the computers in the network, they will validate these transactions, and there are predefined algorithms to do that, and those transactions will be verified. The transactions can involve cryptocurrency transactions, or something called contract transaction. There is something called smart contracts in blockchain technology, which is being used widely in Ethereum and other private blockchain networks. There is something called a smart contract. You can write computer programs in blockchain network. That is what is called smart contracts, and the program is called smart contract. It helps you to execute transactions. You can update data, you can modify the data, you can share information from one person to another, like the earlier example I said, right? I have shipped a vaccine to so and so. I've send the vaccination tablets to the medicine to you by this particular. I've engaged this particular courier company. They have at so and so time. They have taken the load at so and so time. All those information can be updated onto the blockchain networks through something called as smart contract. You will write programs to update the blockchain ledger, so that those transactions may not involve cryptocurrency. Not every blockchain transactions will involve cryptocurrency. Blockchain is not Bitcoin. Bitcoin is not blockchain. Okay. Bitcoin is a cryptocurrency which uses blockchain technology. Bitcoin is a widely popular cryptocurrency which uses blockchain technology. Blockchain technology can be used in various other applications. It can be used for cryptocurrency transaction. It can be used for data transfer, data sharing, where multiple people want to see the data at the same time. So the blockchain technology allows you to share the information real time. Once you update one computer, it automatically broadcasts data to all the computers. So in those scenarios, we can use blockchain technology. Okay. So these transactions can involve cryptocurrency or any other data. Once the transaction is verified, okay, there are no double spends, and the format of the transaction is correct, the transaction will be combined with, there will be, let's say, in a network, there are thousands of nodes or thousands of computers. All of them are writing data onto this blockchain network and then sending. So in a minute or in a particular second, there could be hundreds and thousands of transactions. Everybody in the computer will get these transactions. They will store the transaction, and then they will validate one by one. All the transactions will be computed and then bundled onto a single block, which is the latest block. That block can contain one transaction or 100 transaction or 200 transaction or 2000 transactions. And it also depends on the size. Okay. Each transaction will have some data, and then it involves some size. Okay. So one transaction will be, let's say it is 100 bytes of data. If it involves two transactions, it can be 200 bytes of data. And if there is a transaction which has more data or information, it can have, let's say, kilobytes of data. So block size also will increase automatically, right, based on the number of transactions. And there are algorithms which say that block size cannot be more than, let's say, 100 KB. After 100 KB, the remaining transactions will be stored, and then this block will be created with, let's say, first 50 transactions are bundled onto one particular block, and that block, let's say it has 100 kilobytes. Okay, that block is then broadcasted onto the network, and there will be one and only one node who will be responsible for creating a block at a time. Okay, so he can create block number 12. Okay, and if he is successfully creating that block, that particular process is called mining. He will bundle the transactions and create the block, and then he will create the block and then say to everybody that I have created the block. Now you all can verify that I have really created this block, and then let's all add onto the let everyone update their own ledger with this particular block. Now I am going to update the my latest block as block number 13. I'm going to add this, so you also do the same. So the computers will communicate to each other, and then they will all agree, and then they will update to block number 13. So there are, say, another 500 transactions pending. So there will be other computers who will be picking up all the other transactions. They will also bundle together. Somebody else will create the block, and then they will say that I have created block number 14. Now everybody update their own ledger. So this process happens simultaneously when there are hundreds or thousands of computers in the network, and there are algorithms to claim that I have created a block. Okay, so that mechanism I will tell you when we speak about mining. That is coming in the next few slides, I think. So this is how a transaction is getting created. Anybody can in the network can propose a transaction, say that I want to send so and so cryptocurrency to person X. Okay, that transaction will be broadcasted onto the network. Somebody in the network, some node in the network will pick up those transactions and then verify that this particular transaction is correct, or okay, you have 100 Bitcoin or 100 cryptocurrency to send. That is validated. The recipient address is validated, whether that address exists or stuff like that. That is address is correct, and a transaction will be written onto the blockchain ledger. Finally, a block will be created, and the transaction will be added onto the block, and then that block will be added onto the network.
I have a query here.
Yeah.
See, from my just somewhat general knowledge and what you have said, there is no middleman. Every computer linked is at par and it works in a network so there is no central agency like in a bank. The bank is having its own network and they do all the. Now here, suppose any transaction is initiated by one computer. So of course there has to be some way that, because if something, let's say we talk about cryptocurrency only, if any Bitcoin, one person is selling, so that order has to be matched with another order. So if there is no, what you call in middlemen, who does it, or is there a software who does all these things?
Software manages all this. It will calculate the transaction whether it will validate whether you are eligible to do such a transaction by looking at all the historical transactions.
But then it has to
all these things happens in
one transaction is initiated here. Let's say he wants to buy a block, some amount of cryptocurrency. Then it has to match with someone. If somebody, because a buyer needs a seller. So how that software will
no. See, buying Bitcoin happens through exchanges. Okay, that is you are giving your fiat currency. You are giving your Indian money. That is happening through exchanges. So a blockchain transaction happens only through Bitcoins or any cryptocurrencies. When you say that I want to buy cryptocurrency, okay, I want to buy Bitcoin. Okay. What the first thing you are approaching a agency? Let's say there is a cryptocurrency exchange. There are a lot of people in India itself. There are a lot of companies like Vazirex or Bitrex or ZepPay. Those are all the cryptocurrency exchanges and companies which help you to buy and sell Bitcoins. So what they do is, first thing what you have to create is a Bitcoin address.
Okay.
You will have to store the Bitcoin address. So what they do is they will take money. They will create a Bitcoin wallet for you. They will say that this is your Bitcoin wallet. This is your address in the blockchain network. If you go and look at the transactions for this address, you will have so and so Bitcoins for whatever amount you have transferred.
So do they have access to this wallet?
They will have, usually what they do is these companies, they maintain their own, they don't give full access to you as a wallet. Just like they say that they will manage these transactions for you.
Okay.
Companies usually work like that.
Okay.
But you yourself can create a blockchain address and then do it yourself. Okay. There are people who do like that. But for doing that, you need a lot of infrastructure and then your own high-speed internet.
High-speed internet.
The common man cannot afford
that was another thing I was going to come, because if you have a bigger public network, and then as you said, every single transaction is updated on all the computers in the network, so that will be a very huge amount of transactions and data and the speed and everything. I understand. Yeah. So got it. So
I will probably in the next session I will show about how a blockchain network. There is a website called blockchaininfo.com. If you go and see there, you can see that in 10 minutes block gets created, and you'll be able to see transactions. I can show you. I can in the next session. I shall open up one particular transaction and say how and explain you what a transaction will look like, how a block looks like, and all those things. Okay.
Okay.
So this is a transaction in Ethereum. I have still have 2-3 few more minutes. I will complete this Ethereum transaction and then show you. So typically a blockchain network, when you are part of a blockchain network, when you have a wallet, okay, your wallet means your address. In order to do any transactions in a blockchain network, be it Bitcoin blockchain or Ethereum blockchain, what you need is an address. Okay. The address will be looking like this. It's a long string starting with 0x, indicating that hexadecimal values. Actually, it is of base 16, I think, or base 58 probably. The Bitcoin addresses are base 58, which uses 52 alphabets and 10 numbers, not 10 numbers, 8 numbers, excluding 0 and 1. Okay. Because it gets confused with I and O. Okay, so alphabets and letters, numbers there will be confusion between I, capital, small l, and 1. So those values are eliminated from Bitcoin addresses. Okay. Or there is a private blockchain called multi-chain. I'm referring to that address mechanism. Okay, it doesn't involve 0, L, 1, and O. All these numbers will not be there, but you can see that an Ethereum address has all those values. Okay, it says 98C27BBAEC890. That is a address of a Ethereum. This is how an Ethereum address looks like. This is address to 83FA. Okay, and as I mentioned earlier, address as a public key and private key. You can say that this is account address, and a private key will look like this. Okay, so first address is 98C27. The private key is that B0E964. That is a long string. That is another string which is used as a private key to sign transaction. Sign transaction means in order to execute a transaction, to say that I want to transfer 10 Ether in Ethereum, the cryptocurrency is called ethers. If I say I want to transfer 10 ethers, the address 98C27, whoever is doing the transaction should be able to sign the transaction. That signing and all happens through the blockchain software. It will ask for the key. Ideally, what it does is it will look for the key on a particular folder in your computer. If you have that key in that folder, it will pick up that, and then it will sign the transaction and then broadcast it. And there are other mechanisms. This private key cannot be stored in the network. People store it in a USB stick. Whenever you do want to store, do some transaction, you plug that USB stick there. That information that is called a wallet secure wallet, hardware wallet. You store that key information in a USB stick. Whenever you do want to transact, you insert that USB stick and then initiate a transaction. Then only, that's why it is secure. Nobody else can do a transaction without a private key. So if you lose your private key, you will lose all the cryptocurrencies or the data which is against your address. That is the biggest I wouldn't say problem. That is the biggest challenge involved in Bitcoin or any blockchain transaction. Okay, if you lose your private key, many people have lost Bitcoins because they have forgotten the address or the private key. They've lost their private key, they wrote it somewhere, it's lost, stuff like that. So the interesting fact is that nobody else can also use that. Unless you know the private key, you won't be able to access that Bitcoins which is marked against your address. Okay, and this is another small transaction. I'll show this transaction in my computer just now. I have a blockchain network. After that, I'll stop the session for today. Okay, so turn down something here. This is my Ethereum address. Okay, it says 182.99 ethers. Okay, I'll copy this and then I'll show you how it looks like. Pardon me?
I said, you're a rich man. I said, you're a rich man.
No, this is it's not a rich man. I'm not. This is my private. This is my private network, just to demonstrate how blockchain looks like. I have created this network just only for this session. Okay. See, as you saw that, right, it shows that 182.9947 and several zeros. Okay, it is 182 ethers. Okay, this is my current ether balance. Okay, now I can show you another transaction, which is PFE. It says 113 ethers. Okay, I'll copy this and I'll show you this value also. It will say 130. Okay, so normally I have these two addresses. I also have a private key of this particular information. Okay, it shows I hold these private keys of these things. This is a software which helps me to create a blockchain network. It also shows the transactions, etc., and it will also help me to do a transaction. So what I can do is I'll just show you how to do a transaction. Let me look at my transaction if it is correct. Okay, so 0 to 11. One and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18 zeros. Okay, that is 1 ether. If I do a transaction, it will give me a transaction ID, that is a hash. And now if I execute the balance of 3FE, it will say that I have got 114. And if I say the balance of the first address, it will say 181. Okay, and if I open up this particular transaction, okay, these are all utilities which help me to show that analyze the transactions in a blockchain network. Usually in a public blockchain network, we can, anybody who does the transaction can verify all this information is open in public. So I can say that this particular transaction is part of block number 13, and the block's hash is so and so, and it says from address 98C2. This is my from address to 3FEE, right? Yeah, 3FEE. That is F2 address, and the value is this. This is how a typical blockchain transaction will look like. And if I also show you block number 13, it says it has got one particular transaction which is of 5824. That is 5824 is the transaction which I got using this. Okay. So I think that's what I wanted to talk about today. We'll talk about mining and consensus in the next class. I think it's over more than 1 hour just now. Is there any questions on this just now? Anybody, people who understood?
Many.
Or
the more you understand, the more questions you will get.
Yeah.
Really.
It's okay to ask questions. No?
Yeah, fine.
Sanjeev, I just have a question. So anyone in the network would be able to see the balances of others, right? So if I have 10 Bitcoins, that would be known to the others in the network as well.
I doubt whether we'll be able to see the balances of each addresses. That will not be known, but you will be able to compute a particular person's balances by looking at the transactions of a particular person, of a particular address.
Okay. I should be able to.
There are softwares which help you to compute that transactions. I mean balances. So the system software also does that. It doesn't store. It doesn't store the balance in anywhere. There is no such place called address so and so. This is the balance. There is nowhere written like that.
Okay.
Or the software itself computes this balance used by verifying, going through all the historic transactions.
Thank you.